Hey, everybody, this is Larry. This is day two of the January Leetcode Daily Challenge. Though for me, it's just Happy New Year, New Year's, and all that good stuff. Time zone is a little bit weird, of course. But yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. The contest is also later today, I believe. So good luck to that if you're watching this before that, and hope you have fun if you watch it after that or whatever. I'm still trying to figure out. I'm still in Panama City. To be honest, my Airbnb doesn't have a great working desk, so I'm still trying to figure out decide between the couch and the high desk. It's like a table that's really meant for like a bar sitting type thing, like bar eating, hanging out kind of thing, but not really for typing and working on a laptop. So I'm still figure it out because trying to do this contest for me locally in about an hour. And yeah, we'll see how that goes. Anyway, today's poem is pairs of songs with total durations divisible by 60. 10 wins. Medium problem. So yeah, okay, let's see. I mean, I don't think I have much more to say. We'll be solving this all week or month or whatever, as long as I can. We've been on a 640 something day streak, pretty much as long as there is, both in the streak and also the video. So you can look at my videos all the way back 640 days or whatever. Let me know in the comments what you think about that. Anyway, let's actually read the poem. You're given list of songs, duration of t times by seconds, the number of pairs of song which the total duration. Okay. Okay. This is I mean, this seems like just a variation of the two-sum problem, I want to say, except for divisible by 60 makes it actually technically easier, maybe? I mean, I wouldn't say easier in terms of problem solving, but I was just thinking about complexity-wise. I mean, I guess it's just another dimension, which can be, quote-unquote, complexity easier, but yeah. I think the only thing that I would also maybe, yeah, okay, no, I mean, I think we're good. I think the only thing that I might worry about is maybe edge cases, but I'm not sure about that. So let's take a look. So the first thing that I want to do is I want to set up a map so this is kind of, if you really want to like categorize things, and I don't really generally think about it necessarily in this way, but if you really want to, I would consider this problem a sort of a prefix dynamic programming problem. Which is kind of like a weird thing to say, to be honest. But some of that kind of goes off. And I think maybe not. Maybe that's too weird of a thing to say. I don't know. But it is, you just use a dictionary or lookup table or something like that, and that would be do it. In Python, there is a thing called counter. Counter is just really a shorthand with a couple of helper functions of basically a mapping any key to an int, a non, or well, could be zero, I guess. A non-negative int is what I would say, or at least that's my assumption. I wonder if you can do like, does that work or does that crash? Huh? I actually never thought about it. I just assumed, but okay. I guess it doesn't. Okay, so I guess you can have negative values. So I was wrong about that one. Today I learned, I suppose. Yeah, okay. So okay. For some reason, I guess you could go either way on the API. But in any case, so let's set up a hash table, and then now for t and time, let's have a total, which is the answer that we look at. And then we return the total at the end. And then for t and time, then what do we want, right? Let's say we have t. Now we try to figure out what plus this number is divided by is divisible by 60, which is, and so another way of saying it is that, okay, we could play around some formula here for sure. I'll do it on the thing. Let's say, you have some previous value plus the current t. And then now we mod 60 is equal to 0, right? Something like that. I mean, this is like pseudo math algebra, so it's not that rigorous. So excuse me a little bit. So of course, in this case, then and technically this is 0 mod 60 if you want to be strictly speaking, and of course this isn't quite equal. It's equivalence class if you also want to be strict about that. I mean that's not really the right notation. I actually don't. I mean it's like the little maybe something like that. I don't know. Don't know if that's a better notation, but either case, if you really want to be slightly more precise, though it's still not that precise to be frank. And then the idea is that okay, I mean this is simple math. You have t, you want to get previous, so then now you have t mod 60 is roughly speaking minus minus 60, and of course this is without changing anything. This is just this plus 60 is equal to t, right? So then now. Okay, now we're given t. So maybe actually I messed this up a little bit. So instead of putting previous on the other side, maybe we put t on the other side. Same idea, but now we have this, right? So now that we're given t, we just have to kind of add this formula a little bit and then look it up on this table, which is what we have in this counter. So basically now we have 60 minus t mod 60. Technically, if you really want to be strict, at least for Python speaking, though this is going to be more generalized, you don't really need this because Python does do maybe a non-standard thing for negative mods, but yeah. And also, of course, this could still be negative, so we actually want this instead. That's right, yeah. Yeah, and that should be okay. And you can kind of prove to yourself that this is going to be between 0 and 60. The only thing that we have this here is that if t is 60, then this would still be 0 instead of 60. So that's basically the idea. And then now we have this as the previous value that we're going to look up, right? And then total. So this is the number of values that, this is the value that we're looking for, right? This is the value that we want to look up. And how many times did it appear in the past? Well, the number of times that it appeared in the past is just that thing that we have in the lookup table. So we have to add it to this thing. And that's pretty much it, except for then, of course, now you do t mod 61 so that you kind of keep track later. So that in the future you can look it up in a previous thing. Of course, this is going to be linear time and linear space. So I didn't really look up the inputs, to be honest. Or rather, I didn't look up the thingies, but I didn't look up the constraints. But yeah, let's try to put a few more things. Yeah. I mean, this is just a random number, and all, that is just a terrible answer, but maybe not. Maybe that's okay. But this is going to be linear time and linear space. So like I said, I don't really look at the constraints, but just to double check, it is 6 times 10 to the 4th. So that should be way fast enough. Yeah, I mean, unless I did some silly mistake with the modular math, which is, to be honest, very possible. I'm happy about this. So let's give it a submit and see if I get this right. Cool. Sweet. 6:42 now. Not that fast. What did I do last time? Just double checking real quick. Guess I did the same thing last time, except I called it target and I used counter. This is actually exactly the same almost. I don't use end though, so okay. Yeah. So this is gonna be linear time, linear space because this is just one loop, and this is over one for everything effectively. And of course, space is actually that's it. I guess technically it could be linear time, but it's also O of n plus u maybe, where u is the size of the universe. In this case, u is 60. So it's actually technically min of n and u, but notationally speaking, everyone just uses n plus u, so I don't know. But yeah. But you can also say in theory, because 60 is constant, this is all one space. But I just like to kind of generalize it a little bit more. But yeah, okay, that's pretty much all I have for this one. Let me know what you think. Hit the like button and the subscribe button. Join me on Discord. Let me know what you think. I think I already said that already, so I really want to know what you think, apparently. Anyway, have a great rest of the week. Have a great rest of the weekend. Have a great rest of the year. Come back soon. Stay good, stay healthy, to good mental health. I'll see you soon. Bye-bye.